To go to the moon would cost approximately $1 million per kilogram, based on current commercial spaceflight estimates. Indeed, the Chinese have announced plans to send crewed missions to the moon by 2030. However, no definitive evidence suggests they will surpass the United States' timeline. NASA's Artemis program targets a crewed lunar landing by 2026, though delays are possible. It all began when Michio Kaku, renowned theoretical physicist and futurist, stepped onto the stage at a highly anticipated space science symposium in Geneva. He was known for his bold ideas and sweeping visions of the cosmos. But this time, there was something in his demeanor, an urgency, perhaps even a tinge of unease that immediately set the room on edge. The title of his presentation had already sparked waves of speculation. The Moon, a paradigm shift in understanding. Most assumed it would be a discussion of past lunar missions or speculative talk of colonization. But what followed shook the scientific community and the broader public to its core. Before we start, please engage with this content by liking and subscribing for more updates. Kaku began by unveiling new data gathered from a collaborative project involving international space agencies and advanced imaging satellites. These devices, recently deployed around the moon's orbit, utilize gravitational lensing and subsurface radar scanning that had never before been attempted at this level of precision. The findings were not only unexpected, they defied conventional models of celestial formation. The first bombshell: the moon's density readings were significantly inconsistent with its previously calculated mass and core composition. The instruments indicated vast internal cavities, some stretching hundreds of kilometers beneath the surface. These voids weren't just natural hollows or lava tubes. Their symmetrical arrangement and regular spacing suggested structural integrity and engineered design. The moon, it seemed, was not entirely a natural satellite. Kaku stood still as the images displayed behind him. Clean geometric patterns beneath the regolith, energy signatures that pulsed at regular intervals, sections that appeared to be reflective alloys buried beneath eons of lunar dust. There was an audible shift in the room's atmosphere. Scientists leaned forward, expressions taut. Kaku pressed on, revealing thermal imaging data that showed unusual heat signatures emanating from beneath the lunar crust, specifically from these cavernous regions. These temperatures didn't correlate with volcanic activity or residual heat from the moon's formation. Instead, they matched patterns seen in dormant but still active reactor cores. This wasn't guesswork. The data was cross-verified from 3 independent space agencies across Europe and Asia. Something inside the moon was still giving off energy that shouldn't be there. Then came the gravitational anomalies. Since the early Apollo missions, small inconsistencies in lunar gravity had been noted, but often dismissed as measurement errors or local terrain effects. The new data, however, painted a different picture. Gravitational fluctuations were mapped and visualized. They weren't random. They formed a grid-like pattern that correlated with the locations of the voids and geometric anomalies beneath the surface. This grid, stretching from pole to pole, suggested not only an artificial distribution of mass, but also a potential mechanism, perhaps ancient, perhaps dormant, that had once allowed the moon to regulate its position with far more precision than previously thought. Kaku didn't propose a definitive explanation. He refused to utter phrases like alien origin or artificial satellite outright. But the implications of his findings were clear. The moon, long thought to be a byproduct of a Mars-sized body colliding with Earth in the early solar system, might not be what humanity believed it to be. It could be partially constructed, a shell over something else, something ancient, something deliberate. The implications rippled far beyond the scientific world. If the moon was not a fully natural object, then the history of the Earth itself would need to be rewritten. The moon's gravitational effect on Earth is fundamental. It regulates tides, stabilizes our axial tilt, and affects biological rhythms across all living organisms. Its presence has played a critical role in the evolution of life. What if that presence wasn't an accident of cosmic mechanics, but a planned intervention? The room was quiet as Kaku laid out a hypothetical. Suppose an advanced intelligence had placed the moon in orbit. Such a feat would require unimaginable technological sophistication. The moon is disproportionately large compared to Earth compared to other planet-satellite pairs in our solar system. Its orbital mechanics are suspiciously perfect, an almost exact match in angular size to the Sun during eclipses, creating total solar eclipses only observable from Earth. For decades, this had been dismissed as coincidence. But now, with structural anomalies and unexplained internal energy patterns, that coincidence no longer seemed so innocent. Kaku noted that any civilization capable of engineering a satellite like the moon would not be bound by the physics as humanity currently understands them. It would be operating on a level that transcended current models, what he often referred to as a Type 2 or even Type 3 civilization on the Kardashev scale. Such entities wouldn't merely observe cosmic evolution. They would guide it, seed it, perhaps even curate it. He moved on to cultural implications, carefully treading the line between scientific discourse and philosophical inquiry. Throughout history, ancient civilizations had revered the moon with reverence that bordered on obsession. Myths across continents, from the Sumerians to the Mayans to the Egyptians, spoke of the moon arriving suddenly, or of moonless nights before its appearance. Such stories were long dismissed as metaphor or myth. But now, Kaku suggested, perhaps those ancient memories held more truth than modern minds were willing to admit. There was no trace of theatrics in his voice, only the weight of realization. If the moon had been placed, deliberately positioned, what then was humanity's place in the cosmic narrative? Were humans the product of random evolution or the intended result of environmental conditions optimized by external intervention? The moon's perfect tidal lock, its orbital synchronicity, its life-stabilizing effects, these weren't small accidents. They were planetary-scale conditions that enabled civilization itself. Kaku transitioned to discussing timescales. The age of the moon had always appeared slightly older than the Earth, a paradox in most formation theories. But if it were an inserted body, something that predated Earth's current biosphere, then the paradox resolved itself. The moon could have been introduced after Earth cooled, perhaps even with the express purpose of influencing the development of life. He refrained from stating any particular theory as fact. Instead, he urged the scientific community to approach the question with open minds. "We are at the edge," he said, his voice calm but firm, "of a new understanding of our world and our origins." This was not a moment for dogma or territorial academia. This was a time for integration, for astrophysics to meet archaeology, for myth to meet quantum theory, for planetary science to stretch into consciousness studies. And as he stood before an audience of hundreds, thousands more watching via live stream, The questions loomed larger than ever. If the moon wasn't entirely natural, what was its purpose? Was it a beacon, a stabilizer, a vault, a machine? And was it still active in some way that had yet to be understood? The implications sprawled like roots beneath the surface of collective thought. Every telescope turned to the moon took on new significance. Every old myth of sky gods descending from the moon no longer felt like mere allegory. Every satellite image, every mineral sample, every recorded tremor of moonquakes was reanalyzed with a fresh lens. What struck many was not just the scientific audacity of the claims, but the humility with which they were delivered. Kaku wasn't declaring revelation. He was opening a doorway, and behind that doorway lay a future where the moon could no longer be viewed as a passive gray rock in the sky. It was perhaps the most complex, most enigmatic structure within reach, and humanity had only just begun to decode it. The press conference that followed the symposium was subdued, even reverent. When asked whether the moon posed any danger, Kaku calmly responded that there was no evidence of hostile mechanisms, only ancient technology, silent but persistent. Whatever is, or was there, he said, has been watching for a long time. As news of the revelation spread, debates ignited across every corner of society. Was the moon a relic of an ancient cosmic engineering project, a shelter from a forgotten epoch? Could it contain archives, machinery, or even sentient systems now dormant? Universities launched new research initiatives almost overnight. The private space sector, already racing toward lunar colonization, now found itself thrust into an entirely new frontier, not just physical, but existential. Humanity's timeline, once assumed to be relatively self-contained, was now possibly linked to a broader, more mysterious cosmological timeline. If the moon was part of an artificial network, if it shared properties with other moons or planetoids elsewhere, then Earth might not be unique. Other planets might harbor similar satellites, each playing a role in planetary development. The galaxy, once seen as a dark ocean of random stars and rocks, could now be a vast stage of intelligent pattern. And this was not just theoretical. The technological signatures found within the moon's interior regions, although degraded, showed a logic of design, not simply utility, but purpose. The kind of purpose that suggested intention, communication, memory. Kaku's closing remarks didn't focus on fear or awe. They focused on responsibility. If humanity was entering a phase where it would interact with artifacts of unknown origin and staggering age, it would have to do so with maturity, not conquest. The moon wasn't a target to be mined or colonized blindly. It was a partner in Earth's journey, perhaps even its guardian. The revelations Michio Kaku presented had the scientific world spinning. But the tremors didn't stop at the confines of academia or aerospace engineering. In the weeks following his announcement, institutions across disciplines began reevaluating their own frameworks, examining ancient texts, revisiting seismic lunar data, and sifting through decades-old telemetry with fresh intent. As attention turned toward deciphering what this new understanding meant, the moon took on a role humanity had never truly considered before. Not just a celestial neighbor, but a potential artifact. And in this new view, every crater, every anomaly, every unexplained phenomenon took on weighty new significance. One of the most immediately affected fields was astroarchaeology, a discipline that had previously existed on the fringe, often marginalized for its speculative nature. But now, as Earth's only satellite was cast in the light of artificial influence, these researchers found themselves at the forefront. Teams of linguists, symbologists, and ancient historians gathered to comb through myths, cave paintings, oral traditions, and star maps that had for centuries depicted the moon not as an object, but as a presence, sometimes a guide, sometimes a gatekeeper. Patterns began to emerge that had long been dismissed as poetic flourish. In cultures spread far across the globe and isolated by millennia, stories told of the moon arriving after the earth had already formed, changing the tides, shifting the skies, or bringing balance to the heavens. Some tales even described celestial beings descending from the moon, teaching agriculture or astronomy before vanishing. These parallels, previously considered coincidental or imaginative, now suggested a global ancient memory of a time when the moon's role was more overt, perhaps during a period when its true nature was more apparent to early humans. Meanwhile, physicists returned to examining the moon's orbit with even greater scrutiny. Its nearly perfect circular orbit and synchronous rotation had always stood out as anomalies when compared to other moons in the solar system, which tend to have more eccentric paths. Now, the mathematical models behind these orbital characteristics were being reassessed, not with the assumption of natural randomness, but with a question. Could this orbital path have been engineered to produce stable tidal effects on Earth, not just for geological impact, but for biological consequences? Marine biologists and evolutionary scientists began reevaluating the fossil record. Tidal pools, long considered the nursery of complex life, might not have formed in the same way without the moon's gravitational pull. The rise and fall of these pools may have been the precise catalyst needed to force organisms to adapt, to transition, to evolve. In this light, the moon's presence becomes less of a backdrop to evolution and more of a triggering mechanism, an architect of transformation. Even the moon's role in timekeeping and calendar systems began to take on new context. For millennia, human societies used the moon to chart their months, their festivals, their rituals. Its phases governed not only agricultural cycles, but spiritual practices. Religions across the world placed the moon in high esteem, aligning ceremonies with its waxing and waning glow. Now, those patterns seemed less like symbolic choices and more like resonance with a deeper, perhaps subconscious awareness of the moon's foundational role in human development. If it was more than just rock and dust, could it have also been subtly influencing the rhythms of consciousness itself? Another area that quickly drew attention was the phenomenon of transient lunar phenomena. Brief flashes or glows seen on the lunar surface, long debated and often explained away as reflections or geological activity. But with the new data presented by Kaku, these flashes were being reviewed in a drastically different light. Sophisticated imaging tools were now aimed at the regions where such events had been historically recorded. The early results were both confounding and captivating. Irregular energy emissions, sudden shifts in temperature across cold, inert regions, subsurface electromagnetic pulses that didn't correspond to solar activity. These weren't natural glitches. They were signatures of operations or perhaps diagnostics still underway beneath the lunar crust. Lunar seismology, too, entered a renaissance. Moonquakes had puzzled scientists since they were first measured by Apollo mission seismometers. They didn't behave like earthquakes. Instead of dissipating quickly, Moonquakes echoed and rang through the moon's body for extended periods, sometimes hours, like the vibration of a hollow object. This ringing quality now served as yet another piece of the puzzle. When viewed through the lens of possible artificial construction, the prolonged seismic waves made sense. They were not simply echoing through porous rock, but potentially through a shell-like structure, a lattice perhaps, or a system of chambers reinforced by design. As more data poured in from lunar orbiters and radar mappers, high-definition scans of the far side of the moon, long hidden from Earth due to tidal locking, revealed further anomalies, craters that appeared too perfect, ridges that formed angular junctions at unnatural intervals, and, most perplexing of all, regions that reflected radar signals in ways suggesting the presence of ultra-dense materials, possibly alloys that were unknown to current material science. These regions weren't random. They followed a distribution pattern, aligning with the gravitational anomalies Kaku had spoken of. Each new finding layered the mystery further, transforming what was once considered an inert body into a labyrinth of technological intrigue. The notion of the moon being a remnant of an ancient intelligence, be it extraterrestrial or posthuman, forced a philosophical reckoning as well. If such a thing were possible, then the silence of the cosmos took on an entirely different tone. The so-called Fermi paradox, which questions why a seemingly infinite universe has yielded no direct evidence of intelligent life, might now have an answer hiding in plain sight. The evidence was there, just not in the form of blinking lights in the sky or decoded radio signals, but in the structure of the moon itself. An artifact isn't just a message. It's a message embedded in architecture, orbit, and gravitational influence. The concept of the moon as a sentinel began circulating within scientific and philosophical circles. If an intelligence had intended to monitor Earth or to preserve something beneath the lunar crust, then the moon would be the ideal location. Unaffected by atmosphere, tectonics, or biological decay, it was the perfect vault. What might be hidden beneath its ancient regolith? Archives of civilizations past, encoded genetic information, perhaps even mechanisms meant to activate or reveal themselves only when humanity reached a certain level of development. This prospect stirred a renewed interest in future lunar missions, particularly those targeting the previously overlooked regions. Space agencies began adjusting their exploration priorities. Instead of focusing solely on resource extraction or surface colonization, proposals emerged for deep core drilling, magnetic field studies, and high-energy tomography to peer even deeper into the subsurface cavities. One proposed initiative, a joint venture between multiple spacefaring nations, sought to lower seismic pods into known anomalous zones and detonate small charges to map internal resonances more thoroughly. The moon was no longer seen as a stepping stone to Mars. It was a destination in its own right, a complex ancient system hiding technologies or secrets beyond current comprehension. Private aerospace companies took a sudden interest as well, not just for the glory of exploration, but for what might be recovered. Ancient alloys, dormant machines, or even propulsion systems could revolutionize Earth's technologies overnight. The financial and technological race was on, and it promised to unfold unlike any space endeavor before. Speculation extended even further. If the moon were placed intentionally, then by whom and why? Theories abounded, from advanced civilizations that once spanned our solar system to extragalactic visitors passing through, leaving behind testaments of their existence. Some proposed that the moon might be a part of a galaxy-wide network, one of countless similar constructs positioned around habitable planets, each tailored to stabilize conditions and nurture life. In this context, Earth would not be an exception, but part of an experimental pattern watched and maintained over eons. There were even discussions, however cautious, about the potential for communication. If the moon had embedded systems, sensors, or dormant computational devices, might it be possible to awaken them? What protocols would such a system require? Were there specific frequencies, energy signatures, or even mathematical sequences that could trigger a response? Could the moon contain dormant AI observing, perhaps even recording humanity's progress? These were no longer the questions of science fiction writers. They were now real subjects in advanced cosmological forums and deep space engineering think tanks. While many remained skeptical, the tide of disbelief was beginning to erode. The accumulated evidence, taken collectively, made the possibility of artificial intervention not just plausible, but increasingly likely. Importantly, no definitive conclusions were drawn, only open possibilities grounded in data. The shift wasn't toward belief in the fantastical, but toward responsible curiosity. A new kind of scientific humility had taken root, the kind that acknowledged how little was truly understood about the moon and how easy it had been to assume it was simple just because it had been so visible for so long. Psychologically, the shift in perspective affected the public in unpredictable ways. Some felt a sense of wonder or spiritual significance. Others experienced unease, even dread, at the thought that Earth might be under long-term observation or part of a grander schema beyond human control. Artists, musicians, and writers responded with a torrent of creativity. Paintings of lunar machines cradling Earth, symphonies composed around the rhythms of moonquakes, and novels imagining what consciousness might be embedded beneath the surface of that distant gray sentinel. In the halls of academia, curricula were evolving. New interdisciplinary programs merged astrophysics with anthropology, engineering with mythology, and systems theory with consciousness studies. The moon had become a nexus for inquiry, an object that forced the collapse of traditional disciplinary boundaries. It was a bridge between what was known, what had been forgotten, and what might still lie ahead. The moon's silence, once taken as evidence of its inertness, was now interpreted as eloquence, the quiet hum of an ancient mechanism still functioning on principles just beyond the grasp of 21st century understanding. It became, in a very real way, humanity's most intimate encounter with something utterly alien yet impossibly familiar. As exploration plans accelerated, Earth's attention turned to specific lunar regions that had previously garnered little interest. Mare Frigoris, once considered a relatively unremarkable lunar plain, began drawing scientific focus due to its convergence of three anomaly zones: unusual electromagnetic signatures, temperature deviations, and a peculiar geometric pattern in its topography. New orbital scans showed near-perfect circular formations buried beneath surface debris, suggesting that something lay below, possibly ancient installations or buried architecture, shielded by millennia of meteorite impacts and regolith drift. International collaboration quickly took shape in what many began calling the Lunar Archaeology Initiative. This wasn't a search for alien bones or ruins in the traditional science fiction sense, but rather a deep investigation into machine remnants, structural formations, or synthetic materials embedded in the moon's strata. One of the early goals was to deploy nanobots capable of traveling into microfissures in the moon's crust, using magnetometric feedback to identify unnatural alignments or embedded alloys. These swarms, guided by AI, would be the first to crawl into lunar cracks and relay chemical compositions at scales previously unimagined. Simultaneously, theoretical physicists began considering the moon in new dimensional frameworks. Some suggested that the structure of the moon might not conform fully to three-dimensional geometry, that its internal layout could obey higher dimensional logic, camouflaging storage or transport systems within pockets of warped spacetime. If the moon was designed as a multidimensional interface or relay station, then much of its content might be cloaked from traditional instruments. The implications of this theory were staggering. Technologies capable of creating fourth-dimensional folds or storing massive computational energy in non-physical space would require intelligence far beyond our own. Instruments were hastily modified to detect space-time curvature shifts at extremely small scales, potential signs of compacted dimensions or folded architecture. Perhaps the most controversial proposal came not from physicists or engineers, but from a group of mathematicians and linguists working in cognitive theory. They postulated that the moon's internal mechanisms might not be entirely mechanical, but instead operated on principles of resonance, an ancient technology that could interface with biological frequencies, brainwave patterns, or even human consciousness itself. Drawing parallels from cymatics, harmonic resonance, and quantum entanglement theory, they hypothesized that certain arrangements on the moon's surface, crater alignments, elevation clusters, and shadow paths could form a planetary scale interface designed to send or receive cognitive signals. The idea was not that the moon was conscious, but that it might act as a translation device between dimensions or forms of intelligence, not limited to material language. This led to the establishment of the Resonant Contact Project, an initiative funded quietly by several governments and research institutes. Volunteers with highly sensitive neurological patterns, often artists, savants, or individuals with atypical EEG signatures, were exposed to rhythmic light pulses, mimicking lunar reflection patterns and magnetic fields found in anomaly zones. What followed was an intriguing mix of synesthetic episodes, shared dream motifs, and unusual cognitive phenomena. Subjects reported intense visual patterns, emotional surges, and cryptic internal images that many described as memories that were not mine. These experiments were in their infancy, but they hinted at something profound: the possibility that the moon's true purpose might involve not just observation, but subtle interaction with the human mind over extended timescales. In tandem, astrobiologists revisited the question of biological markers in lunar material. Though the moon has long been considered devoid of life, new analysis techniques using femtosecond laser spectroscopy allowed for the detection of ultra-trace organic patterns in deep core samples. A faint signal, composed of complex carbon nanostructures, was found embedded within an impact layer estimated to be over 2 billion years old. These carbon networks were far too structured to be explained by meteorite debris alone and bore no resemblance to contamination from Earth-based missions. Though not alive, these structures could have functioned as carriers of information, biochemical instructions, or even as components of a long-degraded organic computational system. The cultural impact of these findings evolved beyond the initial wave of curiosity. The moon began to influence philosophical inquiry on a planetary scale. In ethics classes and spiritual forums alike, people wrestled with